multiple layers make sense. Our brain works that way. This side optic tract, here magnocellular, here nervocellular, here optic radiation, here monocular region. 1, 2, 3, 4, 5, 6. So our brain works that way. First, second, third, fourth, fifth only. Multiple layers make sense in this way. Many layer, many layer neural network architecture should be capable of learning the true underlying features and feature logic and therefore generalize very well. Okay, so this is it. But until very recently, our weight learning algorithms simply did not work on multi-layer architectures. Along cave deep learning, the new train, the new way train uh, neural networks, neural networks, multi-layer networks. Train this layer first. Train this layer first. Okay. Then this layer. Then this layer. First this layer. After this layer. Train. Train is the very important. Train, train. Go train. Then this layer. Then this layer. Finally this layer. Finally this layer. Finally this. Then we need to multi-layer network. Each of the non-output layer is trained to be autoencoder. Basically, it is forced to learn good features that describes what comes from the previous layer. An autoencoder is trained with an absolutely standard weight adjustment algorithm to reproduce the input. Autoencoder is trained with an absolutely standard weight adjustment algorithm to reproduce the input. Output is this one. Hidden input encode this way, decode this way. By making by making this happen with many fewer units than the inputs. This forces the hidden layer units to become good feature detectors. Hidden layer units become good feature detectors. Intermediate Intermediate layers are each trained to be autoencoders or similar. This is autoencoder or similar. This is final final layer train sorry final layer uh, final layer trained to predict class based on outputs from previous layers. Final layer trained predict class based outputs from previous layer. Output, 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 output. Okay. Output. There are another output. Others. And that is that is and that is the basic idea. There are many types of deep learning, different kinds of autoencoder variations on architectures and training algorithms, etc. Very fast growing area. Input layer. This one. This one already we have seen. Hidden layer. Here output layer. Okay. Feed forward networks for function approximation and classification. Okay. Feed forward networks, deep tensor networks, convolution network. Then second one, here activation function. Then this human being, 10 traits. Here terminal branches of action. This is input. This weightage, summation, integration. Here output, target output. A artificial neuron, single artificial neuron. One here x0, we can say x0 also up to xn, w0, f of x, f of wt of x, w transpose. A single artificial neuron bias node inputs. This is the bias node. So weights. A summation, non-linear activation function. output iteration of the neuron. Output iteration of the neuron. Activation functions. Identity, identity f of x equal to x. Binary step f of x equal to 0 for x is less than 0, 1 for x is greater than or equal to 0. Logistic aka soft step f of x equal to 1 divided by 1 plus e power minus x. Tan h f of x equal to tan h of x equal to 2 plus 1 plus e power minus 2x minus 1. Arc tan f of x equal to tan power minus 1 tan inverse of x. Soft sign f of x equal to x divided 1 plus mod x. Rectified linear unit RE. Rectified linear unit. It is RE for rectified, LU for L for linear, unit for U. RELU. F of x equal to 0 for x is less than 0, x equal for x is greater than 0. Activation function. So you have to remember once again rectified linear unit RELU. RE for rectified, linear for L, L for linear, U for unit. Activation functions. Identity f of x equal to x. Binary step f of x equal to 0 for 0 is less than 0, 1 for x is greater than 0. Logistic aka soft step f of x equal to 1 divided by 1 plus e power minus x. Tan h f of x equal to tan h of x equal to 2 divided by 1 plus e power 2x of minus 1. This is traditionally used. Activation function. This one also I already mentioned, no? Rectified linear unit. F of x, sorry, f of x equal to 0 for x is less than 0, x is for x is greater than or equal to 0. Currently most widely used, empirically easier to train and results in sparse networks. Then perceptron Rosenblatt 1957 used as a binary classifier equivalent to support vector machine SVM. S for support, V for vector, M for machine. Support vector machine. F of x equal to 1 if Wx greater than 0. Otherwise 0, 0 otherwise. 1 bias, here input weightage. So summation here output, target output. This is non-linear. F of W transpose of x. Train weights using examples d equal to x1 d1 up to xx ds. Initialize W with random values. For each example xj, tj. Calculate output yj equal to f of W transpose xj. Update weights W plus tj minus yj of xj. Repeat until to convergence. In perceptron Rosenblatt 1957. Here in the same one and OR XOR operation, output here 0. Here output 1 in this condition.